Good afternoon to one and all. I am Sadiq Ahmed, convener of the webinar. A warm welcome to all the participants to the national webinar on Chemdraw and Chemistry Teaching and Research, organized by the Department of Chemistry, Government Degree College, RAZOLE. So far, we have received 444 registrations for the webinar. Let me first congratulate all of you for taking out your valuable time to attend this webinar. This shows your interest and commitment towards teaching and learning. Our college has been doing so many social and student-centric activities by distributing food packets, grocery bags to the poor and needy, and conducting online classes, quizzes, and counseling to students. Although we have been taking online classes since second lockdown, in one way or other, this webinar is to skill our chemistry teachers with knowledge of 2D molecular editing software like Chemdraw. This pandemic has become a challenge to teachers to update themselves. Many of us are quite comfortable with chalk and pack method and finding it difficult to adapt to online teaching. One great man said that we grow by facing our challenges, not by our comfort. Our participation has shown our willingness to face the challenges. Online teaching provides a number of advantages over offline work. One such is that we can record our video and see our class any in teaching and work on them. Moreover, we can draw the structures in colors, which helps the slow learner understands the concepts easily. We can even share the structures drawn in the software to students in PDF format so that students can revisit them and will come to the next class with better background information. We can even provide additional inputs like chemistry in daily life, drugs introduced in the Indian market, and many more such things. According to one study, a teacher's teaching competency will grow up to the first 3 years of teaching career. Then automatically, teacher's learning stops unless he deliberately wanted to learn. With these introductory words, now I call upon a man behind this program, our beloved principal, Dr. K. Bedras Garu, to present his opening remarks.
Good afternoon, respected faculty members and students. Today, Government Degree College, RAZOLE, Department of Chemistry is going to conduct a national webinar. For this national webinar, we invited an as resource person, Sri, as resource person, Sri Chemdraw, Senior Consultant, Scoop Scientific Software Solutions in Teaching and Research from New Delhi. Chemdraw Garu, warm welcome to you, sir. Warm welcome to you, sir. I am also inviting all the participants, both faculty and students, for this webinar. I am extremely happy that our college is conducting this national webinar on Chemdraw in chemistry, teaching and research, which is going to be an exceptionally informative and engaging session for the benefit of faculty of chemistry in particular and others in general in connection with the online teaching. Today, all of you are well known about that. Today, we are almost forget about traditional method of teaching. We have already shifted modern methods of teaching. Today we have shifted to teaching from the traditional chalk and board platform to the online modes of teaching, being forced by this pandemic COVID-19 situation. We, the teaching community, must always get updated ourselves with the newer technologies that come into force in technology-enabled teaching. In this connection, I appreciate the head of the Department of Chemistry, Sri Sadiq Ahmed Garu, and other faculty members and supporting staff of our college in conducting this national webinar today. Once again, I request all the participants to utilize this opportunity and enrich your knowledge in teaching chemistry through online. Thank you very much. Thank you one and all. Namaste.
సాదిక్ అహ్మద్ గారు సాదిక్ అహ్మద్ గారు
సార్ చెప్పండి ఎవరు సార్?
నేను రమణమూర్తి ఫ్రమ్ విశాఖపట్నం.
సార్ చెప్పండి.
Except the host and co-host, please request everybody to mute their mic as well as the video, sir. Otherwise,
Okay.
so much disturbance will be there. Please.
Okay, sir.
Thank
Definitely.
you. Thank you.
Thank you. Thank you, sir, for your inspiring words. So, in this webinar, the resource person will talk about the following topics, like Chemdraw, drawing with parties, name to structure, structure to name, generic structure, ring color fillings, copy paste from Smiles, Inchi, Helm, TLC, gel electrophoresis, stoichiometry calculations, predicting NMR spectroscopy, adding variable attachments, searching with ChemECX, PubChem, GHS, LCSS, Chem3D, ChemScript, ChemFinder, Chemdraw, Novalite, and finally Signals Notebook. So let me wholeheartedly thank Mr. Chemdraw Gaur for accepting our invitation on behalf of our Department of Chemistry, GDC RAZOLE. Now I request all the participants to follow certain guidelines for the smooth conduct of the webinar. Please mute the video and audio. Don't press the present now button during the webinar. That will disturb the presenter screen. During webinar, if presenter screen becomes small, please click and pin to the presenter screen. After the keynote address, there will be a question and answer session in which you can pose your questions to the resource person. I request all to pose your questions in the Google Meet chat box. Or else if you cannot do it, you can do it in the WhatsApp group also. I will collect them and post them to the resource person in the question and answer session. While you are trying to rejoin in the webinar, if you get a screen that Google Meet is filled, the maximum number has been reached, you can even watch the webinar on the YouTube link provided in the WhatsApp group. Thank you. Happy learning. Now I request our keynote speaker, who is master in using Chemdraw software, Mr. Chemdraw Gaur, to present his talk. Over to Chemdraw Gaur.
Thank you very much, sir. Thank you to all the participants and all the organizers. Let me just share my screen. So I hope all of you can see the screen.
No, sir.
Yeah, can you see the screen?
No, sir. No. No, yes, sir. Yes.
Yes, sir.
Hello. Yeah, can you see the screen?
Yes, Charitra, we can view the screen.
Okay, perfect. Okay, so first of all, same thing. I request all the participants to mute their audio and also their video options so that I can show you the demo uninterruptedly. Okay, so we were talking about the Chemdraw 19.1. So the latest version of the Chemdraw is 19.1. First of all, I would like to introduce myself. My name is Charitra Gaur, and I am working as a technical consultant in SCube Scientific Software Solutions. And academically, I am medicinal chemist and working with the Perkin-Elmer with other our principals. So today's session we will cover uh, the ChemDraw templates, right? Then we will cover ChemDrawing with hotkeys. So instead of mouse, you can draw the structure with your keyboard. Name to structure, structure to name generation. Then we have generic structure bracket expansion for one unit or for multiple units. Ring color filling options. Then we have copy paste from Smileys and Kai and Helm toolbar. Helm is for biopolymer. TLC gel electrophoresis drawing. Then we have stitch metric calculations, Helm toolbar, define dictionary. Then we will talk about the predict NMR, add variable attachments. Then we will search our substructure or structure with the Chem ACX, PubChem GHS lab chemical safety summary that is also incorporated in the Chem office. So this is all we will cover in the Chem office. So all of these things that I'm showing you is included in Chem office basically. Then we have a Chem 3D. Then we have a Chem script. So if you are doing the scripting part or programming with the Python, and this would be very much useful for you. Then we have a Chem Finder in Chem Office. Then we have Chemdraw MNOVA Lite. Then Signals Notebook or Signals Electronic Lab Notebook. That is basically a cloud notebook. Okay. So Chemdraw is chemical drawing tool since 1985, right? So there are earlier versions, and the latest version is Chemdraw 19.1. It is publication grade quality. There are some style sheets. JHeterochem is there. Village document is there. So likewise, because all the particular journals have their particular parameters to draw the structure in order to publish your particular paper, right? Then user friendliness, chemical intelligence, that I will show you how we can draw the structure in a quite faster way. So Chemdraw brings you molecule, chemical reaction, biological entities, and pathways from idea to publication at unprecedented speed, right? So the conventional way to draw the structure with the Chemdraw is with the help of mouse, but now they have added the hotkeys, right? So here we have a whole bunch of chart for the hotkeys. If I press 0, it will be a single bond. If I press 1, it will be a single bond in the same direction. And likewise, 2 will add the carboxylic group. Likewise, 3 adding the benzene ring, right? 4 secondary carbon. Likewise, 5, 6, 7 cyclohexane, cyclopentane. Likewise, right? So in this way, you can draw the structure in a quite fast manner. So if you can see below, if I press Z, it would be a triple bond or alkyne group. If I press O, it would be a carboxylic acid group, functional group. Right? what are the latest feature in the Chemdraw 19.1? So ring coloring option is there. Just draw your particular ring and you'll be able to add the colors within your rings. SciFinder N is there, so integration of SciFinder and SciFinder N. Both are there in the Chemdraw. So if you have a free access, or not free access, if you have a access of SciFinder as well as reaccess, right, then you would be able to show structure and substructures. So the difference between SciFinder and SciFinder, and that in SciFinder you will have extended features and the functionality for the retrosynthesis part, for patent informations, for particular reactions methodologies. Right? Then we have PubChem lab chemical safety summary. So if I draw the acetone, I can select it, and then I can fetch the lab safety information directly from my Chemdraw worksheet. Then obviously Helm toolbar is there. So Helm is basically hierarchical editing language for macromolecule. So it facilitates you with the protein, with the DNA and RNA fragments. Right? So accordingly, you just choose particular amino acid and then expand your structure, and you will be able to get the whole bunch of structures. When we're talking about the licensing part, so Chemdraw is available on Windows as well as Mac with 3 packages. Chemdraw Prime, which is basically you can draw your structure and copy paste to your MS file or MS document. Along with that, some hotkeys part is there with the Chemdraw Prime, and also some physiochemical properties can also be fetched. Chemdraw Professional includes all the features and the functionality of Chemdraw Prime. Then we have biopolymer option, Helm. Then we have Chem 3D. Then we have Chem Excel. Ring coloring option is there in Chemdraw Professional, and SciFinder N is also incorporated in Chemdraw Professional. Then we have Chem Office Professional, which includes all the features and the functionality of the Chemdraw Professional, along with lab safety summary, PubChem. Then we have interface for third-party software. So if in your system, like Gaussian or Gamers or Autorock is installed, then Chem 3D is as a interface to set up your input file, and would be able to calculate the properties with these third-party softwares. Then we have Chemdraw MNOVA. So MNOVA Lite basically. So we can get the information about analysis or peak picking and integration for 1D NMR. Signals Notebook. We will cover Signals Notebook for Signals Notebook for the cloud, right? Cloud accessing. Okay. Just so for any information, you can drop a mail to info@scubindia.com and charitra@scubindia.com. Okay. Okay, just a minute.
సార్ మీ వాయిస్ క్లారిటీగా వినిపించడం లేదు సార్ నాకు.
Charitra, can you be a bit loud on your voice? People are saying that they are not able to hear you properly.
Okay, but I hope you can see the screen, right?
Yes, your screen is visible. Yes.
Yeah. Okay.
People, please stop presenting the screen. If you try to present, it actually causes a disturbance to the session. And if you're not able to view the screen in full, click on the screen wherein you see the presentation and hit the pin option. When you hit the pin option, it automatically maximizes the screen. So that way it minimizes the other people within the screen. You can see pin to screen option. Just click that. So only the screen of the presenter will be viewable to you. Can others stop? Yeah, please stop presenting the screen. Sai Sundar, please stop presenting.
Okay. So I think you all can see the screen, right? This is my Chemdraw. Okay.
Sir,
Hello.
excuse me.
Yes,
Sir,
sir.
excuse me. Please disable the chat box. Somebody is presenting and interrupting your screen presentation. I could not see your screen presentation, sir.
That is not in my hand. I can't do
Of course,
anything.
you please ask the organizers, sir. Please ask the organizers.
If Mr. Sadiq can hear me, kindly disable the video option or sharing option for the participant so that I can share
Chat box
my
also. Chat box also.
chat box also.
The chat box.
Chat box can be closed by individual user by just clicking the X mark on the meeting details. So that way you will not be able to see the chat box, and you will be only seeing the screen.
Yes, sir. Disable the chat box, sir.
Okay. So I hope now you'd be able to see the screen.
Yes, sir. Yes, sir.
Okay.
Please the volume, sir. Please keep the microphone at your mouth. So
Yes.
Low.
Okay. Okay. So let me start with the demo session. Because every time if I get hampered with these sharing screen and technologies, so I could not able to present the software. So okay, so what I can do is first I would able to create a template, a Chemdraw template, right? So if you can see here, there are the templates for the advanced biodraw, amino acid chains, amino acids, anatomy, animals, aromatics, bicycle, bioinstrument, bioart, bugs, clipware, conformers, right? Cycloalkanes, DNA templates. So there are all a bunch of templates are there, so that you can just directly select it and then press once to your working file, and you would be able to get that particular structure. Now, how to create a user-defined template, right? So what I can do
Sir,
is
please do share the screen, sir.
I have already shared the screen. I don't know why you could not able to see.
Madam, click on the presenter screen, pin it. Then you will see presenter screen.
Okay. Okay. So regarding template, so what I have told you is just go to the new template section, right? And then what I can do is, suppose I am repeatedly working with the some metal lines or metal scenes, right? So let's draw this one, right? Now it is added to my template, right? Now what I can do is I am just going to the file, save as, and make sure it should be .ctp file, Chemdraw template file, and then I can save it as things, then save it. And now if I open the template, you can see the empty in my template section. So if you are repeatedly working with the metal scenes, then you can fetch the particular structure directly from your template list and just play it around. Right. Now, let me start the drawing part. So, as I have told you, you can draw the structure with your help of hotkeys. So, what I'm going to do is I'm going to draw a drug molecule called as a tinapanor. So, tinapanor is basically a FDA approved drug in September 2019, and it is basically used as a irritable bowel syndrome. So the purpose to draw this particular structure is that the newer FDA drugs are also incorporated in the Chemdraw, right? Updated to I think March 2020. So whatever drugs that has been approved by FDA incorporated in the Chemdraw itself. So name to structure, structure to name can be done. Now, so name to structure, structure to name, we will cover later part. So let me just begin with this particular drawing. So let me select the benzene, right? Now, if I move my cursor, right, so you can see there is green dot here, right? So it will show you the next direction for the bond. Now, if I press 6, it will be cyclohexane, and just single bond for 1, then click A for benzene, then S for sulfur, okay, 2 for double bond, and O for oxygen. Similarly, N for adding NH2, and 0 for single bond, 2 for double bond, and then oxygen, then N, oxygen.
Sorry, Mark.
Right. Now, similarly, if I okay, let me just add another image, and here should be the N over here. Now, this is basically a repeating structure, right? I would like to get this is not the full structure. So another unit, the same thing should be attached to this NH here. So what I can do is I'm just selecting it, control, and you would be able to get the copied structure, right? And then what you can do is you just need to flip it vertically. So shift plus control plus V, right? And then you need to rotate it 180-degree horizontally. So click on Alt plus Shift plus Control H. Sorry. Let me just go to the check, rotate vertically. All right. So now what I can do is I need to join this particular atom with this one, right? So what I can do is just press Shift, and then Control J. Now you would be able to get the structure. So this is the structure for tinapanor. There are an OH. Similarly, just select it, Control C, right? Go to the object. I would like to flip it horizontally, and then just delete this one and add another atom here. So get CH3, and then press Shift, Control J. Right. Here we have the structure for bempenedoic acid. So in this way, you can draw the structure quite in a few minutes, right? Or few seconds, if I can say. Another thing is drawing the Fisher projection, drawing the perspective views, and Neumann structure of glucose. So what I can do is I just need to get this single bond, right? 1, 2. Okay, then 1, 1, 1, 1, 1, 1. Similarly, OH and sorry, it should be H and OH. Then there should be OH. It should be H, should be OH and H. Now to draw the text part, just press T and you will be able to get the text part. Then CHO.
షూటింగ్ సెన్సార్ CH3 గురించి.
And then we can have CH2OH. Okay. To clear this particular structure, just go to the structure, clean up the structure. And if you can do this multiple times also, right? Control Shift K. Another thing is the Neumann projection. So suppose if I have single bond, then just add hydrogen to the terminal carbons. Okay, and then Same thing, just copy and then attach a bond between this carbon to this carbon, right? Then select orbital part, click once, select the backward area, Control R. You would like to rotate with the 180 degrees. Object, bring to front, and then you will be able to get this one, right? Obviously, it will be showing you this particular warning structure, displaying the warning sign. So, because there are multiple bonds or multiple atoms overlapping with a particular atom. Okay. Now, another thing is the generic structure, the bracket expansion. So suppose if I would like to draw the peptide, right? So let me click single bond right here. Okay. NH, because protein consists of NH and CO or amide group. So to oxygen, right? Now just select this bracket extension, and I would like to get the repeat count of 7. Right now, just select whole structure, then go to the structure, expand generic structure, right? And you'll be able to get the whole peptide. So this is the easiest way to draw repeated units. Another example, if I can show you, is drawing of vitamin K. So just click benzene, click once, then 2 for double bond, 1, 1, 2 oxygen, catching the oxygen, 1, 2 oxygen, right. Then from here, the chain would be there, 2, 3, yeah, right, double bond, right. So now this is not a particular structure for the vitamin K. So I need to get the repetition unit for this part, right? So let me count with 4 repetition unit, and then select the whole structure, expand generic structure, right? So now you can have the structure for the vitamin K. Just let me draw the single bond instead of 2 bond. Okay. Okay. Now, another thing is the drawing the catalytic or cyclic reactions, right? Catalytic cycle reaction or eclipse cycle reaction. So, for example, if I have this benzene here, and I need to draw like this particular cyclic reactions. From here, this is my reactant, then there is an intermediate, and then we have cyclic sort of reactions. So what I can do is I'm just clicking this arrow, right? Then make it to 180 degrees and then drag the head part to here, or what I can do is just need to select it and change the size and the degrees. All right, then just drag the head part. Suppose this is my reactant, this is my intermediate product. Copy it, Control K, and send it back to the arrow. Similarly, drag the head part, drag the tail part. Suppose this is my another intermediate. Similarly, select this, Control K, press Control, drag the head part, drag the tail part also. Similarly, copy it, move it back. Drag the head part and also the tail part. Right. So in this way, you can draw the particular cyclic reactions from here to here. Now, if I can show you some examples that I have already prepared for this particular example, we have Wilkinson catalyst, right? So if you can see here how we can draw the catalytic reaction. Okay. Now next part is the toggling the aromatic display, right? So if I can get the structure for the benzene, it is in the resonance part is it is showing the line structure. So I can go to the structure, toggle aromatic display, or Alt K. Right. So here you can have a delocalized structure for the benzene. Now let me draw another repetition unit called as bakelite, right? So it's basically a thermosetting polymer, a derivative of phenol and formaldehyde. So what I can do is just let me draw this benzene part, and here I can attach single bond OH and one and Z for triple bond, and then this single bond for one, and A and one OH. And in this part, I can attach two bonds here. Okay. This one. Now what I can do is I'm just copy it. Similarly, copy it, keep press Control. And now to join, same thing, keep press Shift and Shift here, Control J. Similarly, shift this one, Control J, right? And then I can attach a bond. Right? So here we have a structure for bakelite, and then if you have a n number of units, then just use Control Shift, Control J, Shift, Control J. Right. So in this way, you can draw the structure quite, fast manner. Another thing is the ring coloring option. So suppose, oh, okay, here we have a warning sign actually. So what I can do is I just need to delete it here and here. And let me join this one like here. Right. Now to color the ring, suppose this first 3 unit, I would like to add the green part, and then another unit I would like to add the yellow part, and for this one I would like to add brownish part. Right. If I show you the examples for the ring colorings, let me open okay. Drugs urine discoloration, right? So there are some drugs which turns the urine into various colors. So rifampicin, like, it will convert to reddish, and nitrofurantoin, it will convert to brownish, cimetidine, likewise, metronidazole, like brownish color, warfarin, red color, amitriptyline, and bluish color. Right. So in this way, you can indicate your colors. Right. And another thing I would like to show you is the heterochemical part. Okay, let me just close this. Yeah, so here you can see the nitrogen containing heterocyclic group or heterocycle nuclei. I have presented with the brownish color, right? And similarly for sulfur containing, that is in the green color, and oxygen containing in blue color, and various multinuclear heteroatoms with different colors. Right. If I go to the file, there are some journal. So according to these journals, you can select and you'll get the structures. So like JHETCAM, molecular med, RSC, right? So ACS document. So accordingly, you can just select it and you will be able to draw according to that particular journal. Then we have ChemACX. So ChemACX is basically the database for getting the molecular information. So here we have ChemACX structure from CAS registry number and ChemACX Explorer. So if I draw any particular structure, then select it and we will get the information about that particular molecule. For example, like phenol, I would like to get the full information. Suppose this one is the product, I would like to get the information. So here we have a supplier, the supplier size. If there's, you will get the price here, purity, and the catalog. Similarly, the properties, we can get the properties from here. So now let me just go with the suppose so here we have a caffeine structure, right? And then what I can do is just go to the CX. I would like to get the full information. Search it. So here you can see the CAS number 58082. So from here itself, you can also get the information and the structure for caffeine in the Chemdraw. So here you can see the suppliers, the size, their particular price, purity. Right? All these things can be traced down from here. Similarly, properties, and if there is any safety protocols, then it can be shown in this safety tab. Similarly, the add-ins, like as I've told you, search SiteFinder. So if you have an access of the SiteFinder or SiteFinder N or Reaxis, then you can get the substructure part, substances. So it will show you the login part, right? So from here you can get into your username and password, and you would be able to get the structure and substructure information. PubChem GGS LCSS lab chemical safety summary, right? So we will get the information about what are the lab safety protocols according to EU regulation, European Union regulations, according to European Chemical Agency, SCIS, Hazardous Chemical Information System. Right? So from here you can just copy the particular source to your working window, and you can copy the precautionary statement code also. This is the new one, new add-in that has been incorporated in the Chemdraw 19. Okay. Same thing, like if I know the CAS number for the particular structure, for example, 305-01, I think this is for chrominon. So it will retrieving the structure. Yeah. So here we have the structure. So name to structure, structure to name is there, CAS registry number is there, right? So there are a bunch of methods that you can get the structures. The copy paste options, like the Smiley's name is structure, INCAI, mole, FASTA DNA, RNA, HIL, right? So from here you can just copy from your particular document and just paste the particular structure to Chemdraw and we'll be able to get the structure. Helm toolbar. Let me just show you the Helm monomer toolbar. Right. So here we have amino acids. Then we have RNA fragments. Some chemical groups are there. So for example, let me draw glycine, histidine, isoleucine, threonine, leucine, alanine, and glycine, right? Now what I can do is I just need to select this, right click, go to the atom, expand label, and you will get the structure. Similarly, for RNA fragment like adenine, cytosine, guanine, thymine, just need to press the button, right click, go to the atom, expand label. You will be able to get the structure. If I can show you some examples, like this DNA fragment I have drawn. So A, C, T, D, then we have 3 to 5, 5 to 3 structure. Cyclic peptides can also be drawn. For example, let me go with this M, D, then we have L, W, M, R, L, right? And then what I can do is I just need to make a single bond between residue 1 to residue L, right? And then just select it, right click, atom, expand labels. So here you can see the cyclic part. In similar manner, you can draw the lactone bridge also. So for example, if I have H, then we have G. Randomly, I need to choose this. So yes. Now let me draw single bond between fragment 3 to fragment 4, sorry, 5. And then right click, go to the atom, expand label, then you will get the structure with the electron bridge. Okay, another thing is the stoichiometric calculation. So this is quite nice, not a nicer way to get the structure because you can also draw the structure with the tool section, but what I can do is I'm just using name to structure part. So like hydrogen. Okay, all right, we have hydrogen. Then we have oxygen. Okay, I also have oxygen, right? Now what? Then I need to draw the reaction, right, to form the water. So I'm just type the water. Okay, I have water molecule also. Now just press plus over here, and once you scroll the mouse pointer to arrow, it will distinguish between which one is the reactant and which one is the product. Right. So just double click to select whole reaction, go to the structure, clean up the reaction. Okay, let me just draw this part. So we have water, we have oxygen, and we have a hydrogen, right? Now, to get the percentage yield of this water, what I can do is just go to the structure, analyze stoichiometric calculation, right? Now, we have 1 mole of hydrogen, we have 1 mole of oxygen, and in the reaction, we have 1 mole of water. So I think there should be 2 hydrogen here and 2 water molecules should be there. So in the molarity, let me just enter 2 moles, and for the oxygen for 1 mole, sample mass. So suppose 2 moles, so 2 into 2, 4 grams. And for oxygen, I would like to show all oxygen has been consumed to make a water, so 32 grams. Now for the water, let's just say the measure mass is around, I'm not going to get the full product because I don't want it to be 100% pure, so let me do 32. Here we will get the percentage yield calculation, right? So what you need to do is you can just enter the sample mass of the reactant and what will be the measured mass after consuming the experiment. Then you would be able to get the percentage yield. Now another thing is the retrosynthesis part or synthesis part. So let me go with the okay, I have a structure. Now here we have a fragmentation tool, fragmentation for forward reaction and for retrosynthesis. So suppose if I cut this part, right, because aspirin consists of salicylic acid and acetic anhydride. So here we have salicylic acid, but we need to draw the acetic anhydride. So should be okay. Should be oxygen here. Sorry, my mouse is slow, so H2O H3. Right. So in this way, you can draw the reaction part quite faster way. And similarly, if I have a retrosynthesis part, so what I can do is let me choose this retrosynthesis fragment. And now if I cut from here, it will show you the reactant, product and reactant. Obviously, you need to draw this part. Okay, so synthesis, retrosynthesis can be done. To draw the simple reaction, or suppose this is just for the example, just select it. Now what you can do is control arrow and you can get the reactant, the intermediate and the product likewise. Right. Variable attachments and multi-center attachments. So suppose I would like to get the structure for nitrobenzene, aniline, phenol, and all the functional group that is attached with the aromatic ring. So what I can do is, let me just draw this toluene, right? Now, just double click to get the text part, and in the bracket, I need to add all the the functional groups. So two, I would like to get an H2 also, then CH3 also, then OH also. I would also like to get some halogens like Cl, Br, and bracket close. Now select it, go to the structure, expand generic structures, right, and you will get all the bunch of structures individually. Okay. The similar manner, I have the example. If I can show you our groups variable attachment, right? So here I have in the variable attachments, I've just drawn the structure and attach this part, then this part, then there will be the R groups. Here in the box, I have defined the R groups, R and R1. This is the R and this is the R1. And their ring, right, from ring ranges 2 to 4. Now, I would like to get the structure for all these things. So just select it to the structure, expand generic structure. Now there are 144 structure will be generating. Right. So here we have all the structures with the R groups, with the functional groups, and with various variable attachments. So this is quite useful if you are working with the scaffold studies. Right. Now, NMR part. So here we suppose if I have this ring, which and then this like here, right? Then just select it, go to the predict 1H NMR, and you will be able to get the structure with the NMR part with their particular solvent is CDCl3 with 1000 megahertz. Now you need to, if you need to change the settings for NMR, so go to the preference, Chem NMR. So there are only 2 solvents are there, and of course you can also change the frequency from 60 megahertz to 1000 megahertz. Right. Now let me do this comparison for the frequencies. So here, if I can show the example NMR. So in this document, you can see for this particular molecule, I have generated the NMR in 80 megahertz with the CDCl3 solvent. So here you can see, if you can see the OH peak, it is quite rough. Then here we have the same NMR with 300 megahertz. So from here you can see the peak for which, and then if I increase the frequency to 600 megahertz, so here you can see the peak of which is quite clear and sharp. Similarly, if I increase to 800 megahertz, it is very much sharp now. And then with 1000 megahertz, you can see the difference of spectral peaks, right? So from 80 megahertz to 300 megahertz to 600 megahertz, then 800 megahertz, then 1000 megahertz. So you can see the differences between the spectra, right? And of course, you will get the protocols for all the peak information, their coupling constant, the vectors, atom index. So all the information you can get from here. Okay. TLC gel electrophoresis, that is already here in the toolbar section, right? So you can just drag it on. You can drag the particular spots, this, and you can just manually change to dash, to double spots, and their particular coloring also. Right. This is not the theoretical, chromatogram. This is just for the drawing purpose. And then you can show the RF values. Right. Now, another thing is the multi-center attachment. So if I need to draw the metal scenes like this one, right? This can only be possible with the help of multi-center attachment. Right? So, for example, to draw this particular structure, okay, CP rings. Let me select this part, and then Control C, and just need to rotate it to 180 degrees. So Control R, 180 degree. Perspective drawing can be editable. So this should be a simple single bond. Then if I press W, it would be wedge bond. And now this part, I can add multi-center attachment. For this part, I can also add multi-center attachment. And just add a single bond to here, just add single bond to here, T and FE. And similarly, what you can do is you just need to shift and Control J. And obviously you can change the dash bond. Right. how you can draw the circular alkanes, right? Multicenter alkanes. So what you can do is, if I choose the chain tool, right? Suppose this is 59 chain tools, 59 carbon. Now, I just need to clean up the structure, Shift Control K, right? So Shift Control K is not cleaning the structure. So what I can do is, I just need to attach a triple bond over here. Okay. Now if I can clean my structure, right? Then need to go back with the single bond, then press 3 and then press delete. I need to draw the bonds between here and between here, right? Then Control A, go to the color, ring filling option. So from alkane, can get the circular carbon chain, and then you'll be able to draw this bulky circular structure. If I can show you the example, here I have drawn the benzene circuit. So there is a 3-unit benzene, then we have 9-unit, then we have 27-unit, and then we have 81 units. Right. Okay. So this is all about the Chemdraw part. So let me begin with the Chem 3D, right? So 3D, to get the 3D structure from the 2D part. Let me just open it. Okay, now suppose if I have a spin, right? Now I would like to get the 3D part. So what you can do is you can go to the view, show Chem 3D hotlink window. Right. So here you can view as a raw. You can do this visualization as a spin, right? And by just launching a one click, you'll be able to get the Chem 3D. Right. So here we have a 2D part, here we have Chem 3D part. Okay, XYZ coordinates are always here. Right. Then we have internal coordinates, atom, bond length. To get the structure in Chem 3D, the one way is, of course, you can draw the structure and get the 3D part, but also there is an option called build from text. right? So now if I or enter ethane, it will showing me the ethane molecule. Right. I recommend you to use Chem3D for the conformational analysis. So to do this, what I can do is I just need to first generate all dihedral angles, right? So in the measurement section, if you can see, there is minus 60 degrees. So what I am going to do is, there is a eclipse conformer and staggered conformer. So eclipse means 0 degree and staggered 60 degrees. To get their particular steric energy, right? So here what I can do is I need to make it radical and convert this to 0 degree, right? And then go to the ML2 calculation, compute properties, and steric energy detail, and click on run. Right. So the total energy is 4.143 kilocalorie per mole, which is quite higher in case of eclipse one. Now, similarly, if I need to get the staggered one, 60 degrees, then I change the dihedral, then go to the MM2, compute properties, and run. Now the energy is 1.134. So it shows that steric energy of eclipsed or 0 degree conformer of ethane is higher than staggered one with the 60 degrees. So ethane tends to move to the, or any other molecule tend to be in a lower energy form. Right? So if I need to get the plot, so we have a single angle plot. So here, if I can press particular cursor, so higher energy is for what eclipse one, 0 degree, and the lower energy is for staggered one. Right? This one, this one, this one, this one. Right. Of course, you can get the surfaces or homolumo surfaces, right? So first you need to go to the calculate surfaces, extended circles, and then when you go to choose the molecular orbitals, so from here you can choose, this is the HOMO, then this is the LUMO part, right? Lowest unoccupied molecular orbital, highest occupied molecular orbital, okay? And similarly LUMO +1, LUMO +2, -2, so accordingly with their particular energies in electron volt. What are the file formats that can be supported with the Chem3D? So here you can see the bunch of file formats. So crystal information file, CIF file, that is also be there. And as I have told you, this acts as a third-party software interface for the third-party software. So GAMUS input file, Gaussian input file, MOPAC input file, PDB file is supported, SDF file, MOL file. So all these files are supported. And if I can show you, so here you can see the complex interface, K-MUS interface, Gaussian interface. So you can directly draw the structure, and if these software are installed in your machine, then Chem3D can act as your GUI, graphical user interface, and you can get the result, and you can visualize the spectra, you can visualize the homolume part, you can visualize the uh, electron density part. So all these things can be done from here. Okay. Right. So another thing is the MM2 or energy minimization calculation can be done. So suppose if I have this ethane, and here if you can see MM2 minimization. So let's, okay. Now in the output, you can see 14 iteration has been run, and the stretching energy, bending energy, torsion with the total energy, right? So this is all about the MM2 minimization. Similarly, MM2 dynamics is also there. So you need to just fix the step interval, frame interval, and heating speed, targeting temperature, and you would be able to get the information for MM2 dynamics. Right. Now, as we are moving to, as we have half an hour remaining, so I would like to show you Chem script part also, because if you are working with the Python, then you can set up the what you can say workflow for your organization with the help of Chem script to share, to save, and to store the chemical data, right? So, for example, I'm just keep open this Chemdraw, and I just need to do ideally.
Third maname fourth.
Okay, now we have Python shell. So with the help of coding, I can draw the structure, I can save the file, I can do the MM2 calculation with the Python shell. And I can also make a script to facilitate my extra bunch of words to, you know, reduce my load, right? So need to, I am not an expert with the coding, but my knowledge is limited to the, my Python language is actually limited to the chem script only. So the first thing is I need to get the script module. Team port, right? Okay, my chem script has been loaded. Now what I can do is I need to draw some structure, right? Like methyl cyclopentane. So to draw the structure in the Python or chem script, you need to have a smileys, right? So for example, like m is equals to structure data dot load data. And the smile is for methyl cyclopentane is CC1 CCCC1. right? Okay, so the data or structure has been loaded. Now I would like to see what is in this particular structure. So m dot list. So here we have 6 atoms, right? And bonds between C1 to C2, C2 to C3 are single bonds, right? We are working with the cyclopentanes, obviously. Now, I need to write the object into CDX format. So CDX.cdx is the uh, file format for the Chemdraw, the native file format for the Chemdraw. So I need to go to the print m dot data, write data to CDX, and should be true. Right. So here you can see in the blue part, the string has been generated. Let me just close my Karnak. Okay. Now I need to get the data in inkai format. So just print m dot write file. It should be write data in inkai. Now I need to save this file in CDX format. So m dot write file. Let me give it name as methyl cyclopentane MCPN, right? And dot CDX, comma CX. Okay, that is okay. So and write file MCPN dot CDX. Now, sorry, it should be in the inverted comma. Right. Now, I just go to this particular folder in which my Python IDL has been installed. So Python IDL. Okay. Okay, so here we have MCPN, right? The folder, right? Now, if I open this, you can see the structure of methyl cyclopentane, right? So in this way, you can, with the help of ChemScript, you can draw the structure, you can manage the storage file, you can make the protocols for sharing to reduce your extra time, right? Okay, so this is all about the ChemScript part, right? And now the last thing I would like to show you is my I think can you see the screen?
Yes, sir. Yes, sir.
Yeah, okay. Because I have got the notification that you are not presenting. Okay, so Signals Notebook. So Signals Notebook is basically the electronic lab notebook, right? In like this is just like our classbook experimental notebook. So we have a notebook in which we have n number of experiments, right? So in the similar manner, we will make the experimental book or notebook, and in that particular notebook, we can have n number of experiments saved in the cloud. So to access the Signals notebook, when you have a Office license, you will get Quite Anonymous Signals Notebook individual edition, right? So once you click on this, you will get the username and password. You need to set the username and password, right? So username is usually the email address. So it's .com and so right, so this is my dashboard. Here I have a notebooks, right? So aldol condensation is one notebook, organic synthesis of Delantin, lab activity on paracetamol. So these all are my notebooks, right? Now, if I open this particular notebook, lab activity on PCM, it just consists of two experiments, paracetamol synthesis and assay of PCM by UV method. So now if I open my experiment, so just like we have introduction, right? We have a theory, then we have a structure. So Chemdraw is incorporated in the Signals notebook itself. The reaction steps, right? So this is the reaction step, stoichiometric calculation, phenol, molecular formula, sample mass, right? Theoretical mass, what solvent I have used. This is all the information I can store in the cloud, right? Then we have reaction step 2, procedure, TLC analysis. So image can also be saved. You can just, suppose if you are working with the TLC, you just need to click and get the photo of your TLC plate from your mobile, and then you can upload it to the Signals notebook. Right? Then we have IA spectrum. So if I need to add any content, I can add a text, I can add a chemical drawing or CDX file format for the Chemdraw. I can add the MS Office part, right? Spotfire file, or I can also upload any other files, right? So if I can show you, and if I can make one notebook, let me. Okay, let me add new notebook. Suppose the name of this notebook is like demo. I can write any description over here, and I just need to select the particular notebook in which I need to add this particular experiment, right? So demo is okay, create experiment, right? Now with the add content, I can add text like production, Right. Then I can write down. So, okay. Right. So just like a MS Word, we have a bold, italic, underline. So some font size, font options. Right. So all these things can be here. And similarly, just let me, I can also drag and drop my files. So suppose, yeah, suppose I have this picture, I have a Chemdraw file, I have Excel file, I have a Word file, right? So what I can do is I just keep press or keep select all these 4 items, and then I can move to Signals notebook. Okay. Okay, it's not showing, so yeah, right. So we have a picture JPG format, and then we can have a CDX file, then Excel file, right? You can directly drag and drop the n number of files, and you can get the visualization in the signals like this. This is image file. So what I can do with the image is, suppose I need to spot this particular, I need to, yeah, this one is my spot, right? And then I can add a text that, yeah, this is my spot. And here, spot 1, I can add the description. So this is for the RF value is like this, right? Like that, right? So this I can do. What you can do is in the history section, if I can go in the history, all that I have done has been saved in the history. So it is just like an audit trail. So so this change I have recently done with my demo 2 experiment. So this thing in this particular date, in this particular time, I have edited the layout of this experiment. I have created the text. So all the things that I have done is saved in the history part. So if you are a guide of, if you have a group with 5 or 6 or n number of, or you can say 10 number of students, then you can check what your students have been done with their particular experiments, right? You can share this particular experiment with your guides, especially students, if they can share their particular experiments. So make sure that only users whose email address belongs to the same domain, like my company domain is the sqbinder.com, right? So I can only share with the sqbinder.com domain persons. This is for the individual individual edition one. When you go to the standard one, you will have another privileges. You can also create a group of your students and can own by that particular group, right? Now, this is the chemical reaction. So in my particular signals toolbook, whatever I have done in the chemical reaction part, that is being saved here. Chemicals, whatever chemicals I have used in my experiments, that is here, right? Now, for the searching option, so suppose if this is my only how much 5 or 6 notebooks I have in my signals notebook. Suppose if I have hundreds or 200s of the notebooks, so that need to be filtered by searching. So I can add the chemical filter here, right? So suppose I need to get the paracetamol. Okay. Okay. So it will show you paracetamol synthesis or whatever the experiment I have done with the paracetamol. Right. Similarly, I can filter the search with the molecular formula, name, product, reactant, supplier, actual mass, right? So there are a bunch of filters over here, created by, edited by, signed by, right? So once the student has shared the their experiment, so you need to sign that particular experiment, right? Suppose this is the experiment of your student, then you can go with the sign and add reviewers, or you can, if you check the experiment and you can get that is okay, and need to go to the sign and close. So then you can go to the sign and close, right? ChemACX, just like as a Chemdraw, ChemACX is also there. So uh, okay, just suppose this is right. So once you open the experiment, you can uh, get the cast number. You can search with the structure and substructure with the help of ChemACX, right? Now, after doing all the experiment, you need to get the PDF of this particular documents, right? Because ultimately you need to uh, get the backup for the whatever the work you have done, right? So now, for example, there is an option called print to PDF, right? You can copy this experiment, you can move this experiment, save as a template. Trash is there, not a delete. Trash is there, right? So whatever you have trashed in the single notebook will store to the trash uh, container. It will not be deleted, right? Because that is a cloud one. So once you go to the print to PDF, output per page, header and footer. I would like to include the history because I would like to know whatever I have done. I need to get that particular information also in the letter A4, A size, right? You would like to get the portrait or landscape portrait and then print to PDF. Now, okay, so here we have generated the PDF. So
ಬಂದು ಸರ್ವಿಸಿಂಗ್
here you can see the demo. The status is active, right? Introduction, procedure, Chemdraw drawing, TLC analysis, report, and their history. So all this thing you can get, right? So this is all about the Chemdraw, Chem3D, ChemScript, and Signals notebook, right? So if you have any question, just let me know, or you can drop me a mail. That is charitra@stbindia.com, right? So I'm sorry if I skip anything because actually I'm not feeling well. So I'm sorry for that. My voice is also quite low because of this. So I'm sorry for that. So if you have any question, just let me know. Or you can post the questions to charitra@sqbindia.com. Hello.
Hello, sir. Thank you, sir. Sir, thank you very much for your very informative talk. We are very
Thank
thankful
you.
to Government Degree College, Rajor.
Thank you.
Now the question and answer session begins. Dear participants, if you have any questions, please unmute yourself and pose to the presenter. Dear participants, if you have any questions, you can either write in the chat box or you can unmute yourself and talk to the presenter.
Sir, how can we get the Chemdraw software, sir?
How you can get the Chemdraw software? You need to purchase this.
Purchase this one, sir.
Yes. So for more information, you can just drop me a mail to charitra@sqbindia.com. I will revert you back with the commercial and technical details.
Okay, sir. Okay, sir.
Yeah.
Is it won't available on Play Store?
No, sir. This is the commercial software.
Commercial software. Okay, sir.
Yes. There is a 14 days trial for the Chemdraw that you can try with that.
Okay, sir.
Sir, can you share that link for free trial Chemdraw software?
Sorry?
Hello, sir.
Yes.
So could you please share the 14-day trial software link in the chat box so that participants can
Trial. For the trial?
Yes, sir, trial.
Okay. So,
Or you can mail it to me. I will share in the WhatsApp group. It's up to you.
okay, no issues. I will mail to you. Or you can simply just Chemdraw trial. So, free trial for the Chemdraw. Right. So you can just get the free trial. SciStore.com is the site. So from there you can get the trial.
It's in the chat box, sir.
Okay, just let me copy this one. And, so that box I have just sent.
Okay, sir.
Okay.
Dear participants, if you have any questions, any doubts on Chemdraw, you can freely ask the presenter, resource person.
Yeah, I'm sorry if I skip anything or because uh, my voice is also low, so because I'm not feeling well, so that's why I'm sorry for that.
If you don't have any queries, we will close the program. Vote of thanks. Please let me know. Mr. Ritra, sir, I think
Yes, sir.
don't have any queries to pose. If they have, they will directly contact you at ritra@cubeindia.com.
Yes.
Okay, sir, we will close our session with vote of thanks. Okay, sir. Now I will request G. Bhaskar Garu, lecturer in English, to propose his vote of thanks. Over to Bhaskar.
ఇప్పుడు లాస్ట్ క్లాస్ గురించి మాట్లాడుతున్నాం అంటే ఆ వీడియో మనం మాట్లాడుతున్నాం చెప్పేయండి సబ్మిట్ చేసాం వాట్సాప్ పెట్టేస్తాను.
Okay, sir, thank you. I propose vote of thanks. Taking the privilege of proposing a vote of thanks, I would firstly like to express my gratitude to Honorable Sisi Amravati for his wonderful encouragement and constant feedback in conducting the webinars. Without whose encouragement, programs like this will never take shape. It is because of you only, sir, programs like this are happening, and without your cooperation and support, programs like this will never happen. And further, I would like to thank Honorable RJD sir, Rajamandri, Sri R. Devan Kumar Garu, for his significant inputs from time to time in this connection in encouraging programs like this, and also programs like this to take place in future as well. Further, I sincerely thank the principal of Government Degree College Razole, Dr. K. Pidraj Garu, the man behind the entire program, and without whose support this program will never have realized, and without you, this program will never realize, sir. We thank you very much, sir. We will never forget your encouragement and support in this connection, sir. I must not forget to thank Honorable Resource Person Sri Charitra Gaurgaru, the man who has full command and mastery for the aspects of Chemdraw in technology, chemistry, teaching and research. We are immensely glad that you were with us today, sir. We will never forget the sessions that you have given today. Certainly, the session that you have delivered today would be of utmost importance for the participants who have participated in this great seminar across India and also from abroad. Thank you, sir, from the bottom of our hearts for your highly informative and engaging sessions today. Indeed, this is a highly useful for the faculty of chemistry department in particular, and also the streams of other departments in general, sir. I must, in this regard, also express my deepest sense of gratitude for the HOD chemistry of GDC RAZOLE, Sri Muhammad Sadiq Ahmed Garu, for his relentless efforts in bringing this seminar to practical shape. And further, I also must thank for the technical support that has been extended by the staff of our college, namely Dr. P. Purnachandra Bose Garu, lecturer in commerce, and Sri K.S.N. Prasad Garu, lecturer in computer science, and Sri K. Gopiram Garu, lecturer in computer applications, for their invaluable work behind the successful conduct of this national seminar today. Further, I also thank the teaching and non-teaching staff of our college for their constant support and encouragement, without whose cooperation, without whose active participation, this program would never have realized. Thank you, sir. Thank you very much, everybody. You have directly and indirectly taken part in making this program a grand success. Thank you, sir. Thank you very much.
Permission out, sir.
Thank you. Thank you, sir.
Thank you.
Final గా
Thank you all the participants. You will get a feedback link to your mail if you missed it in the WhatsApp group or Google Meet. All the participants will get feedback link in their mails in 10 to 15 minutes. Thank you for your participation.
Thank you.
Thank you, sir. That's it, sir.
Thank you.
నా పర్మిషన్ చెప్తాను ఒకసారి పర్మిషన్ ఉంది నాకు గూగుల్ లింక్ ఇస్తాను సార్. इनबॉक्स
అతను భోజనానికి వెళ్ళి సర్లే మనం చూద్దాం 5 చాలా మందికి వచ్చేస్తుంది
అధికారమే చేయాలన్నాడు వాళ్ళు అక్కడ అధికారమే చేయాలన్నాడు
అంటారు సార్
మోడీ నీతుడు ఆర్మే చేయాలని చెప్పి అన్నాడు
ఏమంటాడు
మోడీ నీతుడు ఆర్మే చేయాలని అన్నాడు
మోరు
మోడీ డిగ్నిటీ ఆర్మే చేయాలని
120 మంది అప్పుడే సర్టిఫికేట్ తీసుకున్నారు సార్ 120
అని అడుగుతున్నారు అన్న ఒక్క నిమిషం ఏంటి నీగా డిజైబుల్ అవ్వలేదు ఆన్లైన్ లో ఉన్నానే
సార్ మా గ్రూప్
ఇప్పుడు వస్తా చూడు వాళ్ళకి తెలియట్లేదన్న